Hey everybody, we're back again with our second math tool. Now, we talked a little bit about the metric system the other day when I had you watch a few videos of kind of where the metric system came from, and we learned that it was part of that French Revolution. But it's now time to get into the nitty-gritties of kind of the metric system as a whole, making sure that we're ready to go. And so I'll try and keep this brief, and so it'll clip right along. Feel free to pause the video at any time if you want to write something down. So let's start with this, is that in physics, along with almost all sciences, all numbers have units. When you're in a math class, we write numbers down, 256 plus 15, and you don't have to worry about 256 what? You just 266 plus 15. But when it comes to science, it doesn't mean anything unless you've got a unit that goes along with it. So 256 pencils plus 56 pencils, right, allows us to know more about kind of what our connections are. On the flip side of things, there's a couple numbers here and there, but almost none that don't have units. So when we get used to doing physics, one of the hardest tools for students to remember is when we're doing problems and we're working with things, we always have to write a unit down. So let's get into the practice of kind of units as a whole. First, there are two different things that we want to talk about right now. There's one thing that's called a dimension and the other thing that's called a unit. A dimension, right, is something that you can measure in the world. So an aspect about the world that you can measure. And there's all sorts of aspects of measurements that you could use. You could check out the size of something. You could see how long it is or how tall it is, right? How much space it takes up. You could ask questions about how hot it is or how cold it is or how bright it is. You can ask if it conducts electricity there's all sorts of things that an object or matter can have. So any aspect you can think about of the world that you can measure, that would be a dimension, right? So a dimension is anything about the world you can measure. So some people talk about the fifth dimension or fourth dimension, right? As we're looking our way into it, but there's hundreds of dimensions. Anything about the world or universe that you can measure is considered to be a dimension. Similarly here, a unit is the size or amount or quantity of that measurement. So if I talked about height being something that we're measuring, right? The dimension is height, I might say, well, what unit are we measuring in? Because if you toss just a number out, if I tell you that I'm 6 tall, you might assume that what that meant was that I'm 6 feet tall, which is true, 6 feet and a bit. But as it comes into it, right, the unit is what has to come onto the end of it. It's important for most things. Sometimes we can take guesses, but sometimes it really ruins things if you're not talking about it. My son always wants to know how long is it going to be until something happens. He's 6 years old, so he's trying to figure it out. So if I say, well, it's going to be in 5. In 5 what? 5 minutes, 5 hours, 5 days? He wants to know. And those units matter. So this being the case, let's go ahead and go a little deeper and see what you know here. So let's think about a particular dimension of things that we can measure. And let's start with the dimension of length. In length, there are lots of different units that you can measure length in. Just like I said time a moment ago, there's lots of different units for time. Let's see if we can think about some units for length. One of those units may be a mile, or a foot, or a meter, or a centimeter, or even a light year. A light year is a measurement of length. But there's not just that, there's many more than that. So those are the size of the unit, or the size of the thing being measured is the unit, and then the dimension is the aspect of what's being measured overall. And there are hundreds of these. So let's check something out. Can you name a single unit from these dimensions on the left? Try pausing the video and seeing if you can do it now. All right. Now, if you've come back to this, maybe you've gotten some, let's test out just a few. So there are lots of different units for each one of them. A possible unit for length might be the meter. But we mentioned a moment ago, it could be a mile or a light year. A unit for time might be a second. Temperature might be a degree Fahrenheit, right? Volume, which is how much space something takes up, could be in a unit that is called the cubic meter, which is a meter length, width, and height. Mass could be a kilogram or force in pounds, right? These are just some. Again, there are hundreds for each one of these dimensions. Well, in that French Revolution, they called the System International, or SI, they went ahead and said that there are some specific dimensions about the world that they call our base dimensions, which also have base units. So the base dimensions of things are these 7: length, mass, time, temperature, amount of a substance, electric current, and luminous intensity, which means how bright something is. So those are your base units: 1, 2, 3, 4, 5, 6, 7, right? 7 base units. And each of these base units, or base dimensions, I should say, has a base unit. So length, for instance, is the meter. And that is the only base unit that we have for length in the SI system. So when we're talking about what is the base unit for length, it is the meter. It's not the mile, right? It's the meter. For mass, it's the kilogram, which is kind of a weird one. We'll talk about that later. Time is second. Temperature is measured in Kelvin. Amount of substance is the mole, which you might have run into in chemistry. And electric current is an ampere. And luminous intensity is the candela. So these are all the base units for the base dimensions. Now, we also have some things here to think about in the sense that these dimensions have symbols. And the symbols you can see on the screen there, that mass has a symbol of the letter M. Length has the symbol of the letter L. T for time, big T for temperature. And because time and temperature are often connected on things, sometimes we use Q for temperature, which gets confusing, but we'll get confusing more later. Right now, just know that sometimes we run out of letters, and so we have to kind of mix and match. Electric current, the letter I. Amount of light intensity is C, sometimes I. That's where things get a little weird. An amount of matter is N, or sometimes uppercase N, or sometimes you might see it as a Greek letter, because we run out of letters in our alphabet, and so we have to switch over to a different alphabet, like the Greek alphabet. And so we might use the letter down here, which is the letter mu. The units then are similar, as I mentioned. So the kilogram, we abbreviate that with kg, meter M, as for second, and so on as things go. But these units are important. They're the base units, symbols, right, for those particular dimensions. Derived units, on the other hand, are units that could be broken down into smaller units as things go. This will be more important for us later in this class as we start to use more derived units. Right now, we're going to stick to base units, but let me put a few of them on the screen so you have an understanding. Force, for instance, in the SI system is measured in a unit called the Newton. Other units for force are pounds. But when you get to SI, you measure it in newtons. And newtons can be broken down into base units: kilograms, meters, and seconds. Acceleration is something we're going to study pretty soon as well, and it can be broken down into base units of meters and seconds. Pressure, which is a unit of force per area, is a newton per meter squared, which newtons can be broken down, so you end up with kilograms, seconds, and meters. So each one of these means that you can combine the base units in order to make these derived units, and that will be more important later when we try and compare units to make sure our problems are coming out okay. The metric system is powerful primarily for the fact that we can use kind of these base units and then use prefixes in front of them to scale how big kind of that measurement is, that amount. And those prefixes on the big side of things, you've probably heard of some of these. There's deca, hecto, kilo, and we start to get to the ones you probably are familiar with. So kilo, or sometimes kila, depending on how you pronounce it. Mega, giga, tera, peta, exa, zeta, and yada. Now, many of these have become kind of more famous because of the fact that the computers have been able to use data of this size. You might have heard of a gigabyte. There's also terabytes and petabytes, but you can have that for any unit. You could have a mega second or a terasecond, right? Any of those units at the beginning can put a prefix in front of them to take a look at how big they are. And these are the big ones, and we'll talk more about what that means in just a moment. The small side of things are some that you also probably recognize if you read from the bottom. You've got dessa, centa, milla, micro, nana, pico, femto, atto, zepto, and yocto. And these are getting progressively smaller and smaller. If you think about, if you know anything about a centimeter is smaller than a whole meter. I can even show you a meter on the screen, right? But a centimeter is only about this big. And then a millimeter is only about this big, and a micrometer is only this big, and so on. You'll also notice that on the left-hand side, I have the kind of the scientific notation of these, right, as we're doing it. So you are dividing by 10 a certain amount of times. So if you divide by 10 2 times, then you end up over here dividing by 10 2 times and getting to the 100. So you would cut a meter into 100 pieces to get a centimeter. Or you divide a meter into 1,000 pieces, which is a 1 with 3 zeros after it, to be able to get a millimeter, or this is a millionth, which is a 1 with 6 zeros after it, so cutting them down and making these smaller and smaller. Same thing goes true with the big side of things, but now we're working our way up the other way. So this is a million meters is a megameter, or a billion meters is a gigameter, and so on. So here's the whole pattern all the way up there. I'm going to move my picture out of the way. If you want to take a picture of this yourself or a screenshot and write this down, this might be useful to you as somewhere where you can get back to it later. I can also include in handouts and put them on. But this is kind of our first side of things. So all of the metric prefixes up there, and starting from this middle category, which is right over in here, right, the middle category is from 1. 10 to the 0th is also 1, and then there's no prefix that goes out front of those, okay? So let's go ahead and take a look at the next thing here. That's all I did for this video. Excellent. So nonetheless, there it is. And we'll use these base units and derived units and move from one to the next in the next video. So thanks. Bye.